ScotAsh was established in 1999 as a joint venture between Blue Circle Industries and Scottish Power. The main aim was to develop value-added, sustainable products based on the fly ash arising from burning coal at Longannet and Kirkensey power stations. The profit-sharing JV was the first of its kind between a cement manufacturer and a power utility, and paved the way for long-term investment in employees, fly ash storage, blending, packing and processing plant. The success of the JV can be measured in terms of the numerous environmental awards, including 2 Queen's Awards, for innovation in 2005 and for sustainability and the environment in 2008. One of the key aspects underpinning the success of the ScotAsh business was to be able to offer a quality product backed up by excellent service, independent of the quality of fly ash arising from the power station. Power stations are there to produce power, not a good quality ash for selling into the market. The amount of carbon left in the ash through incomplete burning is one of the main measures of ash quality. The ability to remove this carbon was then seen as a critical element of the business strategy. After extensive due diligence, ScotAsh decided to invest in the ST equipment and technology triboelectrostatic separation of carbon from the mineral ash. This was based on its much lower capital cost and ease of operation compared with its main competitor at that time, carbon burnout. The ST-ET separator has been in operation for over 14 years and has proven to be a very reliable and efficient means of removing carbon from the fly ash.
One of the critical factors when developing cementitious products based on fly ash is the quality of the fly ash itself. By quality, I'm referring to the carbon content, or LOI. The carbon content can vary considerably, and often it's depending on how the power station is being operated at the time. So when we were making the investment, we had to have an idea of how we could actually process the ash to remove the carbon. In those days, there were 2 commercially proven technologies. One was the triboelectric separation of carbon, and the other was the carbon burnout. We did extensive due diligence on both processes. Both processes, in fact, work quite well. The main difference was the capital cost and complexity of the carbon burnout, so that is why we ended up choosing triboelectric separation.
After 14 years of operation, the separator has been very reliable and easy to maintain. The key areas of maintenance include the belt, the rollers and the bearings. We've had up to 600 hours off a belt. The capacity of the separator is between 25 to 40 tonnes per hour. We run an average of 32 tonnes per hour. This is due to the quality of the ash. The typical feed LOI for this particular machine is between 8% and 22%. Our target LOI is 4%, but we have managed to go below 2% if required. We control quality by a number of ways. One, the speed of the belt, the feed rate, and also the ports. The material comes through the weigh hopper, into the distributor, into the ports, into the belt. From the belt, it enters a pump on either side, the low carbon and the high carbon side.
The typical yield from the separator is between 70 and 90%. Depending on the quality of the ash, we normally achieve about 82%. The separator is easy to start. It normally takes a few moments before we're producing good ash, but when it comes to shutting down, it normally takes a bit longer as we have to run the whole ash out of the system. We control ash quality by regular testing of the ash LOI, and if we need to make any adjustments to the separator, we can change the feed rate or speed of the belt.